I have a confession to make. When I saw the topic for today's deep dive, my brain it immediately started playing a very specific mental movie.
Let me guess. Does this movie feature tweed jackets?
Tweed is definitely involved, but it's mostly the setting. I'm picturing, a dusty, silent archive.
Mm-hmm.
There are those green banker's lamps, the smell of old vanilla and crumbling paper, and someone wearing white cotton gloves carefully turning a page. It feels analog, slow.
It's a beautiful image, isn't it? That romantic ideal of the solitary scholar communing with the past.
Exactly, it's comforting. But then I opened the research packet you sent over based on this presentation by James Hudson, and it felt like the soundtrack just changed from Mozart to, I don't know, heavy techno.
It's a bit of a shock to the system.
We aren't talking about magnifying glasses. We're talking about neural networks and biometric surveillance. A massive shock. I mean, are we talking about the Renaissance or Blade Runner?
Well, the argument in today's source material, Art History in the Age of Artificial Intelligence, is that to really understand the Renaissance in the 21st century, you actually need a bit of Blade Runner.
And that is the tension we are unpacking today. Is the robot coming to replace that scholar in the dusty library?
Or is it just a really, really high-tech pair of glasses? James Hudson calls it the human-machine synthesis.
Human-machine synthesis, okay.
And the mission for this deep dive is to trace that evolution. We're going to look at how the field is moving from the magic lantern, an old-school projector, to the neural network. And this isn't just about cool gadgets.
Right.
It's about a fundamental shift in how we see, how we study, and even how we walk through a museum.
So let's start with the timeline, because my biggest takeaway from the first few slides was that my romantic movie of the art historian, that's actually a bit of a myth.
It's the aha moment right out of the gate. We tend to view technology as this sort of alien invasion on the humanities.
Yeah, that it's something new.
But Hudson argues that art history has always been about methodological ingenuity. It's a continuum.
I was surprised to see the timeline start way back in 1767. I don't usually associate the 18th century with tech.
But it absolutely was. That's Johann Winkelmann. He's often called the father of modern art history. Before him, looking at art was very disorganized. He established standards for visual evidence using copperplate engravings.
So copper plates were the JPEG of 1767.
That is actually a perfect analogy.
Yeah.
It was a technology that allowed visual information to be mass-produced, to be distributed.
So you didn't have to be standing in Rome.
Exactly. You could study the data, the image, remotely.
And then the timeline jumps to the 19th century and the magic lantern, which frankly sounds like a Dungeons and Dragons item.
It does, doesn't it? But it's really the great-grandfather of the slide projector. And that changed everything because it turned static descriptions into a visual narrative.
You could tell a story.
A lecturer could sequence images, tell a story. But the big conceptual leap, and this is key for understanding AI, comes in the 20th century with André Malraux.
The museum without walls.
Le Musée Imaginaire.
Mm-hmm.
Photography allowed scholars to, cut images out of their context. You could take a photo of a French cathedral and lay it next to a temple in India. You could strip away the geography and just compare the forms.
So you're processing the art as information separate from its physical place. You're creating a database, essentially.
Precisely, before databases existed. And that brings us to today. Hudson argues that the neural network is just the next logical step. We've gone from copper plates to what's called distant reading.
Distant reading. I've heard that term used for literature, where you feed 1 million books into a computer to find word patterns. How does that work for paintings?
It's a very similar idea. Instead of close reading, standing 2 inches from a canvas, you step way, way back. You ask a computer to look at 1 million images at once.
1 million.
The AI isn't seeing the painting like we do. It's analyzing pixels as data points to find patterns that are just too vast for a human brain to process.
So it's not replacing the human eye, it's seeing things the human eye literally can't because of the scale.
Exactly. It's the difference between walking through a forest and looking at a satellite image of the forest. Both views are true, but they tell you very different things.
Okay, that scale is hard to wrap your head around. So let's bring this down to the ground. The actual experience of me on a Saturday walking into a museum. Because the sources talk about this shift from a universal museum to an intelligent museum.
Right. Think about the last time you went to a big traditional museum. What was the vibe?
Impressive, a little intimidating, big white walls, quiet, and lots of those little placards with tiny text that I, pretend to understand but usually just skim.
That is the temple model. The information flows one way, from the curator, the authority, to you, the passive visitor, and it's usually one size fits all.
And that one size usually assumes I know a lot more about Baroque brushwork than I actually do.
That's the universal visitor model. It assumes everyone has the same background. But we know that's a myth. The intelligent museum, powered by AI, moves to a dialogic model.
Dialogic meaning a conversation.
Yes. The museum speaks to you, not at you. And the best example in the research is the Civic Art Gallery of Ascoli. They're using GPT-4.
The same tech behind ChatGPT. This part blew my mind because audio guides are they're just recorded MP3s. This is different.
Completely different. It adapts in real time. So let's say you're standing in front of a portrait of a nobleman from 1530. The system assesses who you are. If you are an art scholar, the AI knows that. It'll point out the brushwork on the sleeve, noting it's characteristic of the Titian workshop, and discuss provenance.
Okay, but what if I'm not a scholar? What if I'm, say, a smart fifth grader?
Then the AI pivots. The source material gives this specific example. It says something like, this guy was a very powerful leader. Think of him like a modern CEO.
But he wore fancy velvet instead of a suit.
Exactly. CEO in velvet.
That is brilliant.
It makes the connection instantly relatable. It explains that the rare blue pigments signify wealth, just like a fast car might today. It turns a static object into a story that resonates with you.
It creates a profile for the user. But looking at the notes, it's not just about making it fun for kids. There's a serious inclusivity angle here, right? Radical inclusivity.
Absolutely.
Yeah.
Museums can be overwhelming, crowded, noisy, visually chaotic. For neurodiverse visitors or people with sensory processing issues, that environment is a massive barrier.
It can stop them from going at all. I saw the Met was mentioned with their sensory-friendly map.
Yes, they use predictive analytics and sensory mapping to identify quiet zones. The system knows, based on real-time data, where the crowds are, where the noise is rising, so if you need a break, the app can guide you to a sanctuary.
That's using data for empathy. I love that. And then there's the language barrier.
Oh, absolutely. AI-driven natural language processing, or NLP, solves that instantly. The Louvre and Tipapa Tongarewa are using apps that provide instant translation. But even more, they offer plain language conversion.
Linguistic equity.
Exactly. So if the curator wrote the description in dense academic jargon, chiaroscuro, contrapposto, the AI can just simplify it. It democratizes the knowledge.
It basically says you don't need a PhD to appreciate this.
You don't.
Okay, that all sounds fantastic. Personalized tours, accessible language, sensory maps, I'm sold. But now we have to talk about the price tag. And I don't mean the ticket price.
There is always a cost. And here, the cost of personalization is privacy. To give you that perfect tour, the museum needs to know who you are, what you like, and maybe where you're looking.
The sources mentioned biometric tracking. That feels a little surveillance state.
It raises some valid concerns, for sure. Some of these systems track your gaze, literally watching your eyes to see what part of a painting you look at. Or they track your emotional response.
To see what engages people.
Right. The goal is to make the museum better. But who owns that data? And did you agree to be emotionally analyzed just by buying a ticket?
Is it opt-in? That's the key question. And connected to that is the black box problem. If a recommendation engine keeps steering visitors toward Renaissance paintings and away from, say, African sculpture, why?
Is it because the visitor wants that? Or is it because the algorithm was trained on a biased data set that prioritizes Western art?
It could just reinforce the old narratives.
That's the danger. The research points to governance as the solution. Human-in-the-loop oversight. The Smithsonian has a data ethics committee that audits their algorithms for bias.
So the visitor has to be a partner, not just a data point.
Exactly.
So we've covered the museum floor, but I want to go back to that solitary scholar in the library, because the research revolution described in slides 7 through 9 is pretty wild. The good eye versus the computational shift.
This is the core methodological shift. The good eye is traditional. A scholar spends a lifetime looking, developing an intuition, a feeling that lets them spot a Rembrandt. It's qualitative.
It's subjective. You just have to trust the expert because they're the expert.
Right. The computational shift is quantitative. It's about data. And the most exciting application for me is unlocking the dark archive.
The dark archive sounds like a fantasy villain, but it's actually really sad.
It is. It refers to the miles of shelves and archives with handwritten documents, ledgers, letters, diaries that have never been read or indexed.
Because handwriting from 1700 is almost impossible to read.
Exactly. Computers used to be terrible at it. But now we have tools like Transcribus. It uses HTR handwritten text recognition. It can take a scan of a messy 300-year-old diary and turn it into searchable text in hours.
There's that one example in the slides that I loved, the record about a daughter Salvatica.
Yes. Found. A Data Salvatica, age 18. Like a cat she was found.
That gives me chills, like a cat she was found. It's so poetic.
It's a microhistory. A tiny human moment that would have been lost in a pile of paper forever. Transcribus brings it to the surface. It lets us search for the invisible people in history.
It's recovering lost lives, and the toolkit for this is immense. Elicit, iris.ai, connected papers.
It's a workflow revolution. The old way. You spend months in a library hoping you didn't miss a crucial text. Now, Elicit can automate that literature review, parsing 125 million papers.
A superpowered research assistant.
And iris.ai does concept mapping. It can visualize the web between, say, neuroscience and aesthetics. And Ricogito helps with geolocation. You can actually watch the map of art history unfold.
Speaking of history, let's talk about fakes. Because the art market is a high-stakes game, and AI is apparently becoming the ultimate detective.
This is where the machine starts to challenge the master. Neural networks can analyze high-res scans to detect patterns invisible to our eyes, specifically brush stroke pressure.
Wait, so you're telling me it can tell how hard the artist was pressing the brush against the canvas?
Yes, and that is a biometric fingerprint. It's unconscious. A master has a specific rhythm. An apprentice trying to copy the style might get the look right, but the pressure will be different.
So the AI can look at a painting and say, this hand was painted by Titian, but that sleeve, that was the intern.
That's exactly it. And it's getting incredibly accurate. It extends to reconstruction too. Factum Art used digital tech to recreate Veronise's wedding at Cana.
That's the one Napoleon stole, right?
Right. The original is in the Louvre. But Factum Art made a facsimile, a perfect digital clone, down to the paint texture, and put it back in the original monastery in Venice.
Which raises a huge philosophical question. If the clone is perfect, does it matter that it's not the original?
That's the question AI forces us to ask. If the experience is identical, where does the aura of the art live? In the atoms or in the image?
Heavy stuff. Okay, let's lighten it up with the education side. The Leonardo da Vinci AI tutor. I mean, who hasn't wanted to ask Da Vinci a question?
This is an extended reality, or XR, tutor. It's trained on Leonardo's actual notebooks and biography.
So instead of a student memorizing Da Vinci was born in 1452, they can just ask him, hey, Leo, tell me about Sfumato.
And he answers, my approach to painting is rooted in the observation of nature. It changes the whole approach from memorizing dates to dialogic inquiry. You're interviewing the past.
I would have paid a lot more attention in class if I could have done that. But, and here's the big but, we have to talk about the limits. The sources warn about hallucinations.
This is the danger zone. Generative AI can be a very confident liar. It can invent citations that look real, but just don't exist.
That is a nightmare for a researcher.
Which is why the art historian has to become the steward of interpretation. We can't outsource truth. And then there's the explainability issue, the black box again. A neural network might tell you, this painting is a fake.
But it can't tell you why.
Right. It just sees a mathematical inconsistency. It can't say the shading on the nose is wrong. It just says, does not compute. You can't publish a paper saying the computer says no, but I don't know why.
So explainability is crucial for acceptance in the field. And then there's copyright.
Right. Who owns the insights? The consensus seems to be AI generates the data, but the art historian provides the meaning.
Which brings us to the synthesis. There was a Venn diagram in the presentation that I think really sums this all up.
Imagine two circles. Circle one is the connoisseur's eye. That's the human. It's subjective, contextual, emotional. It understands irony.
And circle two is the algorithm's speed.
Quantitative, pattern-seeking, infinite scale, empirical. The new art historian lives in the intersection of those two circles. They're a steward of interpretation. The technology amplifies the labor. It doesn't replace it.
I like that. It's not man versus machine. It's man plus machine.
Precisely. It's about leveraging the machine to do the heavy lifting so the human can do the deep thinking.
So looking at the Future Horizons slide, where are we going?
The slide calls for critical reflexivity. The computational turn is a continuation of the quest to see more clearly. But we need three core values. First, transparency. Be open about data and tools. Second, inclusivity. Use tech to dismantle barriers, not reinforce bias.
And third,
rigor. We can't use AI to shortcut intellectual labor. We have to use it to deepen it.
It sounds like a new golden age for the field if we keep our hands on the wheel.
I think so. But here is a final provocative thought to leave you with.
Let's hear it.
We talked about how the algorithm can find patterns across millions of images that are invisible to the human eye.
Right. The distant reading.
So, if we are analyzing patterns that no human can actually see, are we discovering the history of art? Or are we just discovering the history of the data we fed it?
Wow.
And does that distinction even matter if it helps us see beauty we missed before?
That is going to keep me up tonight. Are we seeing the art or just the math behind the art?
It's the big question.
From the dusty archives to the neural network, thanks for joining us on this deep dive.
A pleasure.
See you next time, everyone. Keep looking closer.